I want the kids to not just focus on the energy part, but the fact that it's clean energy. So our project was on wind energy. And so this is something that's beneficial, helpful to the environment. So the kids could always have that consciousness of thinking about energy. We have to think about the environment and do something that is renewable.
I think it's obviously always important that kids stay focused in science and engineering and give them the opportunity to be interested in those things.
Energy is something that is encompassed in everything we do. So they'll be able to take that knowledge about energy and just apply it to things that they do every day.
In order for us to advance, we're going to have students that become scientists and engineers, and we need those people to be able to make advancements. You have to have people studying to develop new materials and products and to create ways that are sustainable.
What I do personally is I try to optimize processes in the plant. So we look at a problem and then we try to address it and make it better. So fix like energy saving projects or environmental projects.
My job title is Process Monitoring Engineer. So a lot of that is to find gaps and apply dollar amounts to them and try to close those gaps.
My current job title is Operations Engineer. I am one of the governing bodies over a particular part of the process. And what I'll do is I'll analyze the process daily to assure that we are maximizing its effectiveness.
I'm a contract support specialist and I handle all the administrative side of the engineers' projects.
My favorite subject in school is science because it sparked my learning for school.
Science, always. I love science.
Whenever I grow up, I want to be a marine biologist.
I love science.
Science, for sure.
I love science.
I do like science.
I love science. Probably a forensic scientist, something around those lines.
Because it doesn't just apply to one person, it applies to everyone.
I just think it's interesting that, you know, you get to look at the world from a different perspective of everyday life, just normal people, and then scientists know way more.
Having some type of STEM education is important because a lot of jobs nowadays have some type of math or science integrated into them.
I believe that it is extremely important to keep our kids engaged in the science and math and things of those natures so that we can continue to be innovative.
I have a very close connection with science, and I think once you're in the STEM field, you can dispose a lot of myths about science, and you start to realize everything that you're using that involves science. A lot of times people don't recognize everything that they're using, from the fibers in their clothes that are no longer just cotton fibers, they're actually manufactured fibers so that they last longer, to the dashboards in their mothers and fathers' cars. It could come from a gas. I mean, whoever thought about that would come from a gas. So it's all about connecting, first tearing down the myths, and for sure building up their future, because without science we can't grow.
Science is the bedrock of future innovations. So kids have to be interested. Nowadays, a lot of kids don't go into science because they believe it's hard. They believe it's a difficult subject. But programs like this do help them, get them engaged and help them fall in love with science.
My name is Nick Cosby. I'm here with Chevron Phillips.
My name is Brendan Fox. I'm also with Chevron Phillips, and Nick and I are both engineers at a Chevron Phillips plant here in Beaumont, Port Arthur. And today we're going to talk a little bit about a forces concept, and we've got a little demonstration here to kind of show those forces in action.
Here we have this bike tire. We're going to suspend it from this little rope around a peg here. So you can see that at equilibrium, it's going to lay completely flat. So, question to y'all is, if we stood this upright and I spun it, what do you think would happen?
It'll stay spinning.
It'll stay spinning. What about the orientation? Do you think it'll stay upright?
Yes.
Why do you think that?
Because you're holding it there, and if you're holding it, it won't move.
Okay.
So let's see what happens. So now you can see it holds an upright position pretty well, compared to the way it was before. It's sort of a difficult concept, honestly. And so when we first spun it, right, you have a little bit of force that's just causing the wheel to spin around the axle, right? And so the force acting there is pretty obvious. You've just got whatever way you're spinning it, either it's going this way or going this way, and you're going to keep it rotating. But when we start giving it a lot more speed with which it's spinning, there's actually another force that starts acting on it. And it's going to be perpendicular to that spin force. So it's either going to go this way or it's going to go this way depending on what direction we spin it. And when that happens and it's going fast enough, when we let it go, it starts to go upright. So what's kind of an application you think that applies to on something you guys probably all have done before? Bicycle. Bicycle, yeah. Right? So that's basically the concept of why you're able to stay upright when you're riding a bicycle. And so when you're controlling it and you're trying to turn, you just kind of lean one way or the other. And it allows you to sort of stay upright because you've got those two different forces acting.
So if you start spinning it.
Okay. Okay.
Okay. So go ahead and grab it right there, and then grab the other side too. Now twist it. So twist in one direction. Do you feel the forces? Do you feel a force acting on you?
It's like turning me.
Yeah, it's like turning you, right?
Yeah.
Okay, so take this and go ahead and you can grab the wheel to stop it. All right. If I get it going really well, and I hold it like this, one of the things is as you turn it, there's a force that acts opposite direction that you turn it. Have you guys ever seen cyclists or motorcyclists ever take a corner or take a turn? What do? They lean into it, right? So when they lean into it, there's a force acting opposite the way they turn. And if you guys want to try it, you can actually feel that force acting opposite.
Yeah, it's like a fresh breeze.
That's cool. Do you feel the force acting?
Yes.
I have a question. Okay, so on a bike, normally it's just the front tire that's turning.
Okay.
What would happen if both the tires were turning at the same time?
Basically, if you had two different tires that were both turning, as far as like on the axes they might not go the same direction. So more than likely you'd end up spilling out. That's why you have one bike tire that turns. The other is when you are turning, if you do get to a point where you lean, it's actually more effective to lean than it is to try and turn. And the reason is when you turn, it's such a jarring motion using the handles themselves rather than trying to lean into it.
So one other thing that we'll point out on the first time we did it, when we spun it and it started standing upright. What else was it doing while it was spinning and standing upright? You guys remember?
Maybe we'll demonstrate again just to see.
Yeah, we can give it another go. It's going in a circle, right? So here's a question for you guys. We spun it in a certain direction, right? And it's standing upright and it's spinning in a circle. What would happen if he spun it in the opposite direction? So right now it's going like this. What if we spun it like this?
Yeah, so now you can see it's going the opposite direction. So you guys knew that it was going to go the opposite direction. Why do you think that is? Centripetal force? Okay, but there's a rule that we can count on when we recognize which direction it's spinning. Do you guys happen to know what it is by chance?
Newton's first law?
Newton's first law, do you know what it is off the top of your head?
For every action, there is an equal and opposite reaction.
Yeah, but what was one of the things, so when I first was talking, we talked about when you're spinning it, you've got a force obviously acting to keep the tire spinning, but once it gets going fast enough, there's another force, right? And I said it was perpendicular. And so the rule that Nick's talking about, and you guys may have learned it, may not, but it's a pretty easy one. It's called right-hand rule. So if this tire's spinning this way, you curl your fingers the way that the tire's spinning, and whatever direction your thumb is pointing, that's the direction that the force is acting toward on the rotation. So if we're spinning it this way, it's spinning like that, and you've got another force acting in this direction. We go the opposite way, fingers are turning this way, force is going in that direction. So that's why when we spin it different directions, it starts turning different ways because it's got forces acting in different perpendicular directions.
There's two opposing forces that cause it to stand upright when you spin it fast enough. There's one that occurs at the top and one that occurs at the bottom. So they actually cancel each other out, and that's what keeps it upright. But as the force lessens on the top, or I guess in this case, I think it depends, but as it lessens on the top, it'll start to go outward, right? So that's what ends up happening is your force at the bottom ends up bringing it back down to that equilibrium. It's pulling that force at the top downward. The other thing is as you can see on this, we don't have this perfectly center. Your center of mass for this particular tire is going to be at this center point, right? However, in this case, wherever we're holding it, our center of mass has changed, and that's due to the part that we've given it an arm. This is our axis, right? You can see it was upright, and as the axis starts to change, as the force lessens, the axis starts to fall and starts to change, and that's what's called precession.
What form of engineering would this be considered, and how does it relate to that form of engineering?
If it had to be in an engineering, it'd probably be mechanical engineering. This is pretty classic mechanical engineering, kind of motion and just mechanical objects. But this is also just a pretty basic physics concept. So as really any type of engineer, this is something you become familiar with, and you'll take classes involving these concepts. And even in high school physics class, that you'll touch on these topics, and this will be a pretty applicable experiment. So mechanical, probably the closest.
Whenever, as the tire starts falling down, does that create an unbalanced force, or does it stay the same?
More than likely it would be unbalanced, and the reason is if you had balanced forces, it would stay upright. If we were in a perfect world, basically it would stay upright forever because you wouldn't have frictional losses, you wouldn't have gravity acting against it, trying to get it back to that equilibrium. So in this case, your force it starts balanced, becomes unbalanced as it starts to fall.
Why do you need engineering in a company that produces chemicals?
That would be chemical engineering, essentially. And so some different concepts at play there. And so we actually both work at an ethylene plant, is what it's called, and that eventually is a product that goes into making plastic. But it's basically a lot of chemistry that goes on. And so I don't know how much chemistry you guys have been exposed to yet, but that's obviously a big part of chemical engineering. And what we do is we take basically gas that comes out of the ground and we turn it into ethylene, which then eventually gets turned into plastic somewhere down the road. So the engineering involved is finding a way to get that gas out of the ground, finding a way to get it to plants, finding a way to turn it into the ethylene, and then finding a way to get that ethylene to another plant that can turn it into plastic. And so, like I said, a lot of chemistry involved, and there's a lot of equipment involved too. I'm sure you guys have seen driving down the road the big tall towers at the different plants and steam plumes coming out and compressors. So there's a lot of mechanical stuff going on in that process as well. But for the chemical part, like you asked, there's got to be a lot of chemistry knowledge there of kind of what's going on, what temperatures we need for this reaction to happen, what pressures we need for a reaction to happen. So that's where the chemical part of it comes in.
So today, guys and girls, we're going to talk a little bit about energy. So there's two main types of energy. There is potential energy and there's kinetic energy. So potential energy is stored energy. So have you guys ever seen like a spring pulled apart or a rubber band? That's an example of stored energy. The energy from me pulling it is stored in that spring. Kinetic energy is associated with movement. So for instance, we eat food and it gives our body energy. That's able to give me the energy to do these cool dance moves. That's a form of kinetic energy. So today we're going to talk about a specific type of energy that's created called electricity and a way that it's formed.
So who knows what this is?
It's a fan.
Okay, you know how it works?
You put it into a plug and it turns on.
Okay, so basically what it's doing is it's taking electricity, electrical energy, and it's converting it to wind energy. Who knows what this is?
It's a windmill.
Okay, so this does the opposite of a fan. So this guy takes wind power and converts it to electrical energy. So these are the blades. For wind turbines, you have two basic types. You have the horizontal ones that have horizontal blades, and then you have vertical ones. This little thing is a shaft, right? And then this little thing is a gearbox, and this is a generator. So whenever wind blows, it turns the gearbox, and then the generator generates electricity. So whenever we start this, if this was outside, you could see it turn around with the wind. But because we're in a room, we would use the fan to get the wind to blow on it. It would spin, and then you could see it. The generator would generate electricity, and then the light will come on. All right. The wind power is being converted to mechanical power and mechanical power is causing the generator to generate electricity. So those are the forms of energy we have. So like she said, we have a potential and kinetic energy. Those are the two main types of energy. But in that, you have different forms. You have the solar energy. So solar energy is actually how the wind forms in the first place. So wind forms by an uneven heating of the Earth's surface. So you have that. You have the wind energy. You have electrical energy that the generator formed, and then you do have the mechanical energy.
So one thing I want to tell you guys is a fun fact that from now on out, your whole entire career in science, to remember that energy is neither created nor destroyed. It's just transferred to different forms. So as Johnson said, it goes from the wind energy to the mechanical energy to the eventually the electrical energy.
How is wind created?
So solar energy heats up the land and the water on Earth, and the land is heated up at a faster rate. So that hot air rises, and the cooler air from the water then displaces it, forming a wind cycle. So that's how the wind is created.
So what are the pros and cons of using these wind turbines?
So one of the cons is that these are very large. We're looking at it at a smaller scale, but it causes a lot of noise. So there's great noise in whatever area it stands. Also, the blades are large and have the potential to kill birds. On a bright side, it's renewable and clean energy, so there's no waste, there's nothing to dispose of, so it's actually good for the environment.
Once the wind passes the windmill, does it slow down or does it go faster?
So let's think through this. We talked about energy changing form. So what happens is we start off with wind, and it interacts with the propellers to turn them, and once it passes, the wind actually slows down because it's lost some of its energy to the wind turbine.
How does the turbine actually create the electricity that comes out of it?
Good question, Gunnar. So you have wind that comes through and then it turns the blades. The wind energy is converted to mechanical energy. Now these generators now generate electricity from that mechanical energy. You guys want to learn how to make a little wind turbine?
So we wanted to start off by saying welcome to Energy Sabine plant. And the first thing we wanted to go over is some safety information. In the event that we had an emergency evacuation, we would go back out that exit that y'all came in to the parking lot, and then we'd make sure everybody was accounted for. So Energy is our headquarters in New Orleans, Louisiana. We have over 30 power plants, and we use a variety of fuels: natural gas, oil, coal, hydropower, nuclear power, and wind power. Here at Sabine, it's all natural gas.
Natural gas is what kind of energy?
Potential chemical energy, so it has the potential to be ignited. So units 1 and 2, unit 2 is retired, and then we have units 3, 4, and 5. We produce 1,890 kilowatt hours of power, which is enough to power 1,360 homes. We have about 81 employees, and our units are running pretty much all the time unless we're in an outage. Okay, so this is a boiler, picture of a boiler. There's tubes that run in the boiler that are filled with water, and we use natural gas as the fuel for the fire. So we heat up the water and convert it into steam, and then it goes through the turbine, rotates the turbine, goes through a generator, and then it'll go through transmission lines and eventually to your house.
How do generators convert mechanical energy into electrical energy?
So as the generator spins, there's magnets inside of the generator, and it creates an electrical field as it's spinning, and that's electrical energy.
So when steam from the boilers is sent to the generator, what kind of energy makes the blades spin?
So it's very high pressured steam. As it goes into the turbine, it would be like blowing on a pinwheel. So the high pressured steam enters the turbine and it blows on the blades and makes the blades rotate. And that's the mechanical energy. So energy cannot be created or destroyed, so we're just transferring states of energy. So water is heated in the boiler and converted into steam, so that's thermal energy. And then we push the high-powered steam through the turbine, and when it blows on the blades, it makes the turbine rotate, which is mechanical energy. And then the turbine is coupled up with the generator, and that has magnets on it, and as that spins, it creates an electrical field, so that's electrical energy.
I thought we burned coal to make electricity. Why do you use natural gas here?
We use natural gas because it's a cleaner burning fuel. We also have access to it here at the Sabine plant. It's better for the environment.
All right, so as like a plant tour kind of the plant, as we can see the plant entrance sign. This is one of our control rooms. As you can see, we have a lot of buttons and monitors to where we can start, stop, and monitor all of our systems. This is a picture of one of our boilers. This main part is the boiler. We have 4 strap fans down here at the bottom that produce the air, and that air fuel mixture makes a fire. All that moves around, and then it ends up going up the stack as all the air movement.
How does the electricity from the power plant get to my house?
From the power plant, it goes through the switchyard, and then from the switchyard, it goes through high-powered electrical lines, and that runs from the plant to your house. This is just one of our motors we have. This is probably one of our largest motors we have. It's probably about 12, 13 feet tall, just so you could see the size of them. From the boiler, it goes to the turbine. As you can see, we got a couple different sections. From there, that's where it spins. And then this is actually one of our turbines from one of our units. As you can see, there's multiple different size blades to it. Next is the generator. On the inside, that's where we said we had the magnets that rotate to produce electricity. And then it goes out to the transformer where it steps up the voltage, and then it goes out to the switchyard, and then to the transmission lines, and then, as Abby said, to your houses.
My dad always complains about how high the electricity bill is. How can we fix that?
One way to cut back on the electricity is to turn all the lights off whenever you leave a room. You can purchase a thermostat that is programmable, so while you're at school or there at work, the AC would be turned up and it wouldn't be running all day while you're gone. Also, dress suitable for the weather outside. If it's cold outside, you can wear warm clothes so you don't have to be running the heater all the time.
All right, what we have here is a model of a basic power plant. What we have is our boiler, which is actually plugged in just to produce the heat. What's going to happen inside the boiler is our thermal energy is going to heat up the water to produce the steam. The steam is then going to go through the lines. When we open the valve, the turbine should spin. When the turbine spins, that's hooked up to the generator. The generator should spin and our little light should come on.
So today we're going to be doing a very fun trick, and I'm going to let these guys do the trick and you guys do the guessing. Is that okay? Sure. Good deal, good deal. So we're going to start off with, I'm going to pass you 1 cup, and I want you to fill it halfway with water. Good deal, good deal. I'm going to give you another cup. I want you to transfer what you put in the first cup into the second cup. Okay. Now I'm going to give you a third cup. Could you transfer the cup of water into the third cup? Thank you, thank you. So we're going to take your piece of paper, the white piece of paper. We're going to hold it over the cups. The other one of you juggle it around, okay? So which cup is the water in? Anybody guess?
The one in the far
Okay.
That way.
Okay, that one. Turn the first cup over in the front. So it's not in that one. Second cup. It's not in that one. Third cup. It's not in that one.
What?
Where did the water go?
Brain. Help.
What?
Where did the water go? This is my magic trick. Is this magic or is this science?
Science.
It's science. It is science. Turn the cup over one more time. Tap it onto the paper. So this material here is super absorbent polymer. They call it SAP for short. Okay? So this is all science. If you guys would look, that was actually powder when we started. See? Everybody see? So, what happened there?
The SAP absorbed the water at a very fast rate, and as it absorbed, it expanded into, it fit the cup, and it just like
Held on very tight. Yes, definitely.
It's flubber.
What's funny is that it only absorbed the water's volume. So it didn't actually grow, it actually just expanded for the volume. So it's the same amount of SAP in that cup. It was just a very little bit in the bottom of the cup. And I'm gonna let you guys experiment.
What is SAP made of?
SAP is made of acrylic acid monomers, and the acrylic acid monomers join together to make polymer, which is SAP, super absorbent polymer.
What exactly is a monomer?
So a monomer is we just talked about acrylic acid is a monomer. And the monomers actually compound with each other and make more and more and more. So mono is one, poly is many. And so you'll always start with that base chemical, which would be your monomer. When it reacts upon itself, it becomes a polymer. So it becomes many. So you go from one to many.
So since you just explained that, that would mean a polymer would be multiple monomers together?
Multiple monomers together. And that's how you get SAP.
Does BASF make SAP?
Yes, BASF makes SAP at the Freeport site. One of the key raw materials, the starting raw material, comes from the Port Arthur site, which Fred works at. It's propylene, which is an olefin. That's the starting material that's used to make acrylic acid, and the acrylic acid monomers are joined together to make a polymer, which is SAP.
So we'll move forward a little bit. What do you think that SAP is used in? Yes, definitely. And we're going to actually get some SAP out of these diapers. But I'm going to give you each 2 diapers. We're going to make one slit up the middle like this. And from there, we will place them into this plastic bag. And if you shake it very vigorously, and you can actually see the polymer starts to come out of the diaper. You see, guys? Here, you pass it around and show you. So if you shake it vigorously, the polymer comes out the diapers. And that's what the kids are using when they're sleeping. The babies are sleeping and they're making a mess. It's not going to be a mess because it's absorbed in these polymers. So each one of you guys can take 2 and get a little shake going on. Good job, good job. I'm gonna start with this water, okay? We're gonna see how much water it absorbs. Okay, give it about 3 seconds. It'll start to absorb that drop and it become hard. You can see it, so we're gonna keep going. I'll do a little bit more. Uh-oh, there, I think it's getting pretty hard. It's one ball. So this is why the babies stay dry overnight, because they can take quite a bit of water for just a little bit of powder.
So can y'all guess how much percentage of water it absorbs per powder?
Let's say 60.
Yes, it can absorb 30 to 60% its own volume. So this is really important to keep babies dry at night. You want to absorb all that water away from their skin so it doesn't get irritated and so they don't wake up.
That's why you've seen the old Pampers used to use a cotton and the baby would stay wet all night. This has made it to where the babies can actually be dry. You can pass it around.
Wow, that's weird.
No, it feels weird.
Can any of you think of any other uses for SAP?
Candles and toys?
Yes, it is in toys.
Yes, they are in toys as well. So the little toys you put in water and they expand to make something else. Sometimes they're in a little ball and they become like an alligator or something when you put it in water. That's where that comes from. It's the same material here.
I feel like it could be used in hospitals for some reason.
They do use it for sanitary cleanup. Matter of fact, you know when you're at school and someone may have an accident, or regurgitate or something on the floor, you've seen that at school. I know we all have. The powder they put down to absorb it. Yes, well, that powder is this. It helps you clean it up and not be able to get on everyone. And so that's for sanitary purposes. I got one that you guys might not know. It's actually used in soil and crops and agriculture. And what they'll do is they'll seed the ground with SAP. And as they water, it will absorb the water and the plants could absorb it slowly instead of being drowned out. Because plants will, if they take too much water, they will die. And so this right here will help you absorb it out slowly. And if it's arid, you go through a dry spell, you'll still have this in the soil, continuing to water the plants. Okay, so we've had fun with diapers. We've played with the powder. Now we're gonna play with the crystals. So I want all of you to take a little water and put into your cups. Anybody want food coloring? And we're gonna move from powder into the crystalline form. Ready? Excuse me. Put a little in yours and let it mix. Put a little in yours. Probably a little bit more in yours. Just a little full. Let it mix. Put a little in yours. Let it mix. A little in yours. A little in yours. A spoon. Mix it in.
While we're waiting for this, is SAP toxic in any way?
No, SAP is not toxic. That's why we get able to use it in agriculture, and that's one of the good uses of it. That's why we're able to put it on our babies' bottoms, because it's not.
Is SAP expensive?
No, it's not very expensive either. You see, a package of diapers is $24 for a large pack. Well, you got the SAP in there. You have cotton. You have other agents in that diaper, right? So in order to keep it affordable for families and stuff, SAP is not very expensive.
Can you get the water back out of the crystals or powder?
Let's have fun with that. I'm going to take this stuff we made earlier, add a little salt to theirs, now start to stir it. And if you notice, her cup should be turning back to more and more towards water. It's getting more clear and clear. You should be able to add a little bit more salt if you want. It'll get all the way back to water. Do you guys know what's happening? Why is it going back to water? Yeah. What happens when you eat a lot of salty chips?
Your mouth gets dry. You have water.
Yeah, you start to get thirsty. So what's happening there is salt has an ionic charge that really likes water. It really likes water. So it starts to drive, just pull the water out chemically. Pull the water out chemically, pull it towards itself. So what's happening here is salt has a high ionic charge that pulls the water out of the SAP, because SAP is only absorbing it. So SAP is only expanding and absorbing it. Well, the salt ionic charge just pulls that water right out. So it's the same thing happens when you eat salty chips and everything gets dry and you want something to drink. It's because of the same effect. Salt will dehydrate the SAP and you will be back to water. So if you tip it over now, it's going to pour out. So the crystals are fairly big now, and they sit up on the spoon really well. And so now you got crystals to play with later on. You can soak out the water with paper towel later on. You got big crystals to play with and mess with your siblings with. Sneeze and throw it on them.
I learned how wind energy is converted through a turbine and changes to mechanical energy, and then that energy goes to electrical energy.
My favorite thing that I learned today was the small polymer crystals can absorb 30 to 60 times their volume.
I hope the kids took away how we make electricity, how it gets to their house, and the different forms of energy.
I learned about how energy is made and what different kinds of energy there is.
I think my favorite part about today was the little crystals that we had that we put in the water.
I
I really liked holding on to the bike as you got to turn it. That was really fun.
My favorite thing, I would say, would have to be spinning the tire and moving it side to side to see what kind of torque it gives off, which felt really weird, but also was kind of cool at the same time.
My favorite thing was when I was holding the tire and it was spinning and I could feel the pull.
I've personally liked learning about everything that's been talked about today.
Playing with the SAP and when we're shaking the bags.
Definitely taking the polymer and mixing all the food colorings into it and it just turning out black.
My favorite thing about today was whenever we created our own windmills.
I loved watching the light bulb light up once the fan started running and all the gears started turning.
My favorite thing was making the windmills because it was fun.
Probably watching the turbine spin and the light up.
My favorite thing that I learned today is probably that SAP can be used in many things such as diapers and toys.